Section 1. Symbols, the building blocks of information. The world is awash in information. We process this information constantly, making sense of the sights, sounds, and smells around us. But how do we do it? How do we take in the raw data of the world and transform it into meaningful knowledge? The answer lies in symbols. Symbols are representations. They stand in for something else, allowing us to think about and manipulate information in abstract ways. A red octagon at a street corner doesn't physically stop our car. However, we recognize it as a symbol for stop, triggering a series of actions that keep us safe. In the realm of computers and artificial intelligence, symbols take on a similar fundamental role. In the digital world, symbols are typically represented as binary code sequences of zeros and ones. These simple digits, combined in countless ways, become the letters, numbers, and commands that make up the language of computers. Just as we use letters to form words and sentences, computers use binary code to represent complex ideas and instructions. This symbolic representation is the foundation of all computing. It allows us to translate the messy analog world into a precise digital format that machines can understand. By manipulating these symbols, we can perform calculations, process data, and ultimately create machines that can learn, reason, and interact with the world in increasingly sophisticated ways. Section 2. The language of machines. Arithmetic and logical operations. At the heart of computation lies the ability to manipulate symbols according to specific rules. This is where arithmetic and logical operations come into play. These operations are the verbs in the language of machines, allowing them to process information and perform tasks. Arithmetic operations are the most familiar: addition, subtraction, multiplication, and division. These fundamental operations are hardwired into the very fabric of computers. By combining these basic building blocks, computers can perform incredibly complex calculations, crunching numbers at speeds unimaginable to the human brain. Logical operations, on the other hand, allow computers to make decisions. And, Oregon, and not. These simple logical operators form the basis of conditional statements and comparisons. By evaluating whether certain conditions are true or false, computers can branch their decision-making, executing different instructions based on the input they receive. These arithmetic and logical operations, though seemingly simple on their own, form the bedrock of all computation. They are the tools that allow us to translate human intentions into machine instructions, transforming abstract ideas into concrete actions in the digital realm. Section 3. From symbols to computation, the algorithm's role. The transition from simple symbol manipulation to meaningful computation requires a blueprint, a set of instructions that dictates how symbols should be processed to achieve a desired outcome. This is where algorithms come into play. An algorithm is essentially a recipe for computation. It outlines a step-by-step process, a series of instructions that a computer must follow to solve a specific problem or perform a particular task. Imagine a chef following a recipe to bake a cake. Each instruction in the recipe, from preheating the oven to combining ingredients, is analogous to a step in an algorithm. Input is the raw material of computation. It is the data that is fed into the algorithm, the symbols that will be manipulated and processed. Just as a chef needs flour, sugar, and eggs to bake a cake, an algorithm requires specific data points to perform its calculations or make its decisions. The algorithm itself is the engine that drives the computation. It takes the input data and, following its predefined rules, transforms it step by step. Each instruction in the algorithm dictates how the symbols should be manipulated, whether it's performing a calculation, comparing values, or storing information in memory.